All right, ladies and gentlemen, today we continue our discussion of the dot product, and we'll be looking at some algebraic properties of that dot or scalar product. So a dot b, b dot a. The thing to remember is the dot product is a number. So most of our real number properties hold true for dot product. We have our transitive property, our a dot b equals b dot a. Same thing with multiplication. If we have opposite of a dot b, that's the same as opposite a dot b. That's kind of like our commutative property. Same thing here, commutative property. If we have k times a dot b, that's the same as doing the dot product first, then multiplying by the scalar. Remember, dot product is just a number. And our distributive property also holds. A dot b plus c, that's the same as a dot b plus a dot c. Now, if a and b are parallel vectors, then a dot b is magnitude of a times magnitude of b. Now, why is that, you might ask? Well, remember, dot product is magnitude of a times magnitude of b times the cosine of theta. Well, what is the cosine of 0 degrees? If two vectors are going the same direction, that is, they're parallel, there would be 0 degrees between them. So we have magnitude of a times magnitude of b. Cosine of 0 is 1. So we have this relationship. And furthermore, if we have a dotted with itself, that is equal to the magnitude of a squared. First example, given that a and b are perpendicular vectors such that the magnitude of a is 5, so it's 5 units long, magnitude of b is 3 units long, evaluate what happens if we have 2 times a minus b, and we take the dot product of that with a plus 4b. Oh, this looks hard, guys. What are we going to do? Well, we FOIL. That's really what this problem is all about. So we're going to follow our basic FOIL principle for if this were two binomials being multiplied together. We're going to have 2 times a dot a plus 8 a dot b minus b dot a. And remember, all these multiplications are dot products. And then we have minus the scalar 4 times b dot b. Well, remember the thing is with a and b in this problem, a and b are perpendicular. So this term and that term, guess what, guys? Those are 0. Remember, the dot product of perpendicular vectors is 0. So we have 2 times, now what happens when we dot a vector with itself? We get its magnitude squared. So plus 0 minus 4 times the magnitude of b squared. Well, we know the magnitude of a and we know the magnitude of b, so we have 2 times 5 squared minus 4 times 3 squared, which is 14. Done. There we go. And when you're done with this, please go back to the beginning and notice that we really are taking one vector, a second vector, and taking their dot product, so we better end up with a real number answer. Second and final example, points A, B, and C have these following position vectors. Here's vector A, so it's a scalar times 3, negative 1, 1. B is here, C is here. Find vector BC. Okay, so remember, vector BC is going to be the terminal point minus the initial point. So BC is going to be C minus B. So 1 minus 3, 1 minus 4, 5 minus negative 2. So BC is going to be negative 2, negative 3, 7. Cool, part A done. Part B, find AB in terms of K. So remember, terminal point minus initial point. Let me back up to the top here. Vector A can be given as 3k, negative 1k, and 1k. That's vector A. So AB is going to be 3 minus 3k. And then 4 plus k. and then negative 2 minus 2k, or minus k, sorry. And now we start multiplying. So we're trying to find k for which the two vectors are perpendicular. Alright, so here we go. We're going to do the dot product of these two vectors. So we're going to do 3 minus 3k, 4 plus k, negative 2 minus k, dotted with negative 2, negative 3, 7. That's what we're trying to find. So here we go. We do negative 2 times 3 minus 3k plus negative 3 times 4 plus k plus 7 times negative 2 minus k equals 0. Remember, these two vectors are perpendicular. We are told that in the problem, which means dot product equals 0. Now we distribute. So minus 12 minus 3k minus 14 minus 7k equals 0. Let me move some of these things out of the way here. There we are. Got plenty of room now. Now we combine up our like terms. So we have negative 6 minus 12 minus 14. That's going to be negative 32, I believe. And then we have 6k minus 3k minus 7k. That's going to be, oh, what do we have here? Minus 4k equals 0. So solving for this, we get k equals negative 32 over 4. So k is negative 8. And there we go. I think I did all my arithmetic right. But there's the end of our section.